Hello and welcome to this presentation. In this video we are going to see how to connect your site-to-site, cloud-to-site or cloud-to-cloud environment using PriCPA, Private Cloud Private Access. This demonstration is all about securing your private traffic. We are going to use the Cloud Security Connector for Zscaler that also has these two functionalities called PriCPA for private traffic site to site and advanced NAT gateway. These two functionalities of the cloud security versus Zscaler allows you to connect your private traffic. This will replace the Azure VPN gateway, and the advanced NAT gateway can replace the NAT gateway on Azure. Then, with a single device, you connect to Zscaler, you connect your internal traffic, and you can go direct to the internet if you want, replacing the VPN gateway. Just the savings on this VPN gateway pays the rest. Okay, the connector brings huge savings to your environment. Let's talk about in general the connector. Well, the use case of the connector is cloud migration first. Is when you want to connect securely your cloud to the internet via Zscaler. Also, the connector offers branch office connectivity. If you want to connect your branch or your data center, or you have a web security appliance and you want to remove it, the connector is a perfect, is a drop-in solution that will help you to replace whatever you have in your local branch and to connect to Zscaler securely. The objective of the connectors, the philosophy, is a product with all configuration, almost everything. You need to put, for example, Zscaler only VPN credentials, and the rest is done by the connector. And on PriCPA, we will see that also brings this simplicity, because you will be able with PriCPA to create a full mesh cloud, a full mesh site-to-site communication with zero trust. Then one of the main objectives of the connector is to simplify your network security. And you don't need to be an expert on networking. You need only to know about subnet, IP, protocol, and port. With these four values, you will be able to manage your entire communications to Zscaler and private as well. Then the next use case, this is all about this demonstration, is private application user access. Then use the integrated PriCPA feature to secure site-to-site, site-to-cloud, and cloud-to-cloud with zero trust. And as we mentioned also, you can secure your egress from your Azure environment using the advanced NAT functionality. Then they will bring more savings to your environment, but also we call it advanced NAT gateway is because you can enforce granular outbound security policies. With the NAT gateway, they offer Azure, you can't. You need to do security groups per VM, or it's very difficult. But with the advanced NAT gateway, it's much easier to do because it contains policies. Let's take a review. This is a high-level network diagram. What Maidenhead Bridge provides is connectors on Azure Cloud, AWS, G Cloud, and also for on-prem that enable you to secure your internet traffic via Zscaler with tunnels. The Zscaler say, first thing first, if you can do a tunnel, do it, and you will have all functionalities in the cloud, not only for web browsing, or also for all port and protocols using firewall in the cloud. Then, if you have a location, do a tunnel. This is the most important thing on the Zscaler setup, because you can protect all port and protocols and all communications and use the entire stack of security that Zscaler provides. In this demonstration, we are going to take this private cloud private access. This is our technology. This is not related to Zscaler. This is the ability. During years, doing connectivity to Zscaler, our customer asked for private cloud private access. Can you do as well the site-to-site communication? Can you do, if this VM want to access this virtual machine on Azure, can you communicate privately using the same connector? The answer is yes. and also with zero trust. And if this VM wants to talk with this virtual machine, we can create policy saying only this VM can get access to this one, but only this laptop can get access to this VM, but this laptop will not get access to this one. Then it has policies uh, per IP port and protocol. And the main problem with cloud networking is cloud networking was trying to adapt what there is in the other end. I know, a firewall, a router, a dedicated link, and at the end, cloud networking has failed because you have multiple solutions: VPN gateway, direct connect, cloud one, cloud firewall, public link, NAT gateway, virtual one, MPLS, network connectivity services, cloud connectivity express routing, and at the end, it's too many pinpoint separate solutions. And if you are in multi-cloud environment, you need to start learning how to do this on Azure, how to do this and the other. At the end, is a mess. Is a mess. Multiple pinpoint solutions, and it's extremely complex, and extremely complex to troubleshoot, extremely complex to create, and it doesn't scale. And the Cloud Secure Connect is the ultimate solution that replace all of these technologies. Here is more clear the problem we solve, and probably you at this point you understand what is the problem, because in modern environment it's not anymore that the branches to one place or to one or two data centers, or these stars or networks, or now you have multiple access and multiple sites and multiple networks and VPN and VNets, VPCs, and different regions on cloud. Then at the end, you need to create, if you want to communicate your entire organization with all teams around your country or the world, you will need to set up a full mesh network. And to achieve a full mesh network with the current technology that the cloud provides, the most common use is you use VPN gateways and use the internet as transport. But suppose that you have, I don't know, 10 sites to connect here. The problem is you will need to do tunnels between each other. And the formula is you need to do 10 plus 9 divided by 2, then you need to do 45 tunnels, IPsec tunnels. It's impossible. And every time you add a new one against the main, it's impossible to manage, it's impossible to configure. This configuration is nonsense. This is where the connector comes to the rescue. And let's take a look about what happened when you use firewalls and VPN gateways. Well, the benefit is the traffic is encrypted and all protocols are supported, because the drawback is the VPN gateways are expensive, and the price is difficult to predict in cloud, because say, okay, if you have such traffic or some many tunnels, this cloud provides 3 tunnels, this 5, this 2, and it's extremely difficult to predict how much it will go. So with the connector, it's a fixed price. Lack of scalability, as I said, we need to create multiple tunnels. It is not zero trust. It will connect any to any. And it's very complex to maintain, because in order to do the routing, the proper routing, you need to implement BGP. Can you imagine to do BGP link by link here? Impossible. Then, what the connector use? We use something called crypto key routing, that is on the kernel of the Linux. On the on the crypto key routing is inside the kernel of the Linux today. And this technology enables you to do, instead to do tunneling directly, to do something more simple, to provision the configuration, that is called crypto key routing. With crypto key routing, it's extremely easy to create a full mesh network. You don't need to be worried about tunnels. We created a software that will enable automatically the creation of the communication. For example, if this laptop wants to talk with this instance, Automatically this connector will say, okay, this subnet want to talk with this one. I will create the encrypted communication to the other connector. Then you don't need to do tunnels in advance at all. And also it's zero trust because it provides a rule that say, okay, if this laptop wants to talk with this instance, yes, you can, but I can create a rule that say only to this instance, and this instance will be invisible for this device. And you can define rules per protocol and port. Then let's take a look at the benefit here. Well, there's plenty of savings. With the calculation, it's about 80% savings if you compare with VPN gateways. It's very predictable price because you pay license per CSC, not per user or tunnel, and you don't need to be worried about how much bandwidth or tunnels you are going to create because the license is flat per connector. Any-to-any communications, full mesh, all traffic is encrypted, all protocols are supported. It's scalable. You can claim multiple PriCPA clouds if you want to do different things. It is zero trust. It's networking as a code. It's very interesting. We will show how you can connect and configure. It's DevOps. Everything is tied to DevOps. The configuration is 2 steps. You need to onboard the node to the PriCPA and deploy policies. Another important point: the traffic visibility is end-to-end. Then this instance will be able to see the source IP of this device. There are other solutions that they are not in everything. Then you will get problems with the logs. You will get problems for things that validate your source IP. You will get a lot of problems. In this case, the traffic visibility is end-to-end. It blocks lateral movement with the zero trust, and its high performance is 1 gig per site. And how is the architecture? What is the secret here? This is the values you need to learn when creating PriCPA. You need to take a subnet that will be for your PriCPA cloud, this subnet. In my case, I'm using 192.168. Then select 24, then I'm able to put up to 255 points here. But the first thing, you need to select the cloud. Okay. At each connector, you will need to assign a cloud of this, an IP of this cloud. IP number 1, number 2, number 3, number 4. Each connector must have a public IP, dedicated public IP. Number 1, number 2, number 3, number 4. And finally, the next value you need to know is the subnets behind. With these 3 values per site, assigning an IP to the node from the PriCPA, selecting a public IP, static, and telling the connector the subnets behind. With these 3 values, you have a full mesh encrypted communication. The connector has the intelligence to create all routing and all tunnels with this. How is this magic? Again, let's take the laptop. The laptop wants to talk with this instance that is in 10.15, I don't know, 100. As soon as this laptop initiates the communication and say I want to talk with 10.15, 100, this connector says, okay, 10.1.5, 100 is behind this public IP. Then this connector initiate the communication to this connector. And this connector will exchange key and say, okay, I accept this one because it is on my configuration, and I will allow to create the crypto key communication. And I will let the packet to reach this device. As simple as that. This association of IP, public, and subnets behind will allow the connector to create a tunnel for you. Then you don't need to do any tunnel in advance. Then anyone with minimum knowledge of networking, with subnet, public IP, private IP, can create a full mesh connectivity with zero trust. How is the configuration? It's 2 steps. The first one, you need to create a local configuration. and this is when the private public keys are created, and the connector will give you this information about the local communication, the local node configuration, and pick up these values and put it on the peers JSON file. This is the most important file in the entire organization because this file, the contents of this file are the local configuration of each node, the subnets behind each node, and the private apps. What are the private apps? This is about zero trust. Then, for example, in this private app, I am allowing this destination 10.2.4.4 from this source IP in TCP 22 and RDP port. This is the only communication. Then this source IP that are my management networks can reach, this is a server, on port 22 and RDP. And nothing else. For the rest is this destination 10.2.4.4 will not be able to be reached. Then you can create rules and say for this destination, for this server, I will allow this particular port and protocol from source IPs you want. Okay, this is our demo environment on Azure. Here we did in the previous video this section, public subnet installation via Terraform, and also we did some setup with high availability for Zscaler. Then on our first setup, we created the tunnels to Zscaler. We created this bypass from Zscaler. This is a NAT gateway functionality. Now we are going to talk about this functionality of PriCPA, this line. And to make it more interesting, and also I need this for the next video that is about traffic forwarding more in detail, I created 3 subnets behind. Then now I have 4 subnets behind the connector, 61, 1, 2, 3, 4. And these subnets, on Azure, from Azure point of view, these 2 are in one route table, and this one 4 and this internal are in another route table. Then this one is a subnet with virtual desktops, and it's a routed subnet. Then the default route is the CSC, and everything is routed. But these servers, I don't want to put a default route to the internet for them. I want to keep them isolated. But I need access from my users to these servers and to this Linux box as well. Then these 2 are isolated from the point of view of the outbound internet access. There is no default route to the internet. They will use explicit proxy and backfile for going to Zscaler. In another video we're going to explain this, but now let's put focus on PriCPA on these lines, and let's configure this to allow my user, for example my PC here, to get access to these 3 these resources. Okay, let's then start working. As I said, we need to create the local configuration first. On the node, we need to add the local configuration to the peers file, create private apps, deploying the peer JSON file. This is the most important file in your organization. And then I need to, with this an extra, configure management networks, take a look at the route and testing. Then let's put things in action. An overview of my Azure environment. I have a Bastion host. Have this Bastion host, and there's 3 machines here and the connectors. Bastion host, connectors, and 3 machines here. In terms of route table, we will forward traffic via the connector. We have this route table internal that contains the full route to the internet is for this one, but these two are in another route table, call it isolated, where there is no default route to the internet, only routes to private networks. And this global proxy, but this is another thing related to traffic redirection to Zscaler. Then we need to control all these things for high availability. Everything is routed via the connector, but I can't get access right now because PriCPA is not enabled. For example, if I want to get access to the internal web server via PriCPA using from my machine, going directly, okay, I forgot to do something. That works magically. Let me correct this. Internal web server via PriCPA edit. Tunnel is enabled. It's going via the bastion, the truth. Now, if I want to go direct private IP to private IP, not via the bastion, it will not work at all. Okay. Good. After we enable PriCPA, this should work. Let me check if I have all this correctly set up. All this communication should fail now. Okay, that's good. That's good. But, for example, if I go via the bastion host, let me show how the bastion host is. This is the IP of the device on Azure Cloud, but I do a SSH tunnel via the bastion host. Okay. Then if I connect via the bastion host, I get access. Let's review. What I'm doing here is getting access from using the bastion host. But if I want to use PriCPA, I can't get access. Then let's enable PriCPA to allow access to all devices on Azure. And we can remove the bastion host after. Then this is the machine via the bastion, and let's exit. Okay, this is the connector. This is the connector number 1. If I do show configuration status here, you will see that well, general information, interface information, public IP information, and bypass public IP. We are going to use this for PriCPA. DNS information, the tunnels are active, blah 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 blah. I'm using London 3 on Zscaler, and private access is not enabled. Okay, and this is the on high availability. This is the CSC active. Then let's configure private access. First step: go to 18, configure PriCPA, create local configuration. Okay, manual configuration, because this is the first CSC. Okay, node name, I will call it this. This is the node location Azure UK South. Okay. Description node video demo. Public IP and port. This is the public IP of the bypass. This one. Public IP and UDP port, and the port will be 51820. Private IP, the IP of the node. Copy, paste, 24. Okay, this if we take a look of the what we're talking about here. Okay, what I'm setting up is the public IP and the private IP. This is needed for the local configuration. Let's come back. Do you want to enable persistent capable IP? Yes. Do you want to apply these values? Yes. Okay. And now this is important values. I will copy these values because I need these values to configure the second CSC on high availability. But first we are going to test this one. Okay. Then next on my demo, well, two steps: create the configuration, local configuration, and peers file. Now I'm going to modify my peers file with the information from the local node. And I will come here and I will need this information to put on my peers file. My peers file is here, and this contains all the nodes on my environment. We have plenty of nodes here for testing purposes. We have a worldwide network with nodes in UK, United States, South America, Japan, and Australia. Then I will add my node here to UK environment. Then I need to come here. Each node has these private apps, but I mentioned to you I need to add the local configuration first. Okay. First step. Second step, let's put the values of my subnets behind. And this is my subnets behind. I have 4, 1, 2, 3, 4. Then let's put 1, 2, 3, and 4. Okay, that's it. And now I need to define the private apps. You can define different private apps, and I need to put here how the private apps works. I need to tell who can get access to these devices in which port and protocols. Okay. Then I will create rules, for example, to allow to I don't know, for example, to get access to this server but not to ping it. We can do zero trust here. Let's put a little effort and create a private apps. For example, I will pick up as example this private app from another node. I will be back here. Okay, then let's create my first private app. Description: allow web and SSH to web SSH to internal web server. Okay. Internal web server. From any one of my organization, I will allow to SSH, and let's put web server. Well, that's not. And the IP of the internal web server is this one. Okay. SSH and port 80 and port 443. Okay, this is one. It's TCP. I'm going to create another one that I will put allow RDP to the set it to win server from my organization, and I will say from anyone my win server is this one. And I will allow RDP 33. Okay. Fine. No. 3389. I was sure I was doing something wrong. Okay, go back. Okay, and finally I will put a rule for the Win desktop for testing purposes only. Well, I will put the other server on the same rule. This one. Put this here. Okay, then now I have my my file and allowing SSH and web for the Linux box and RDP SSH for the Windows machines. I need to upload this file. Currently I'm using a bucket on AWS to store all these files, and on the connector you put the URL of the bucket, and using System Manager you can refresh the devices. Then let me do it now. Then I will do via Terraform the update. This is, let me show my, this is the Terraform template. Then I will update this protocol. This Terraform template, as soon as you update any file here, and you run Terraform plan, it detects the difference on the file, and it will allow you to refresh. Okay, it's telling me this, and apply. Okay, and this is my peers URL. Then this is what I need to configure a second step in my node. And going back to my node here, I did the first step. Now 18, load private access. I will use a URL, paste. Do you want to refresh? Yes. You can view the JSON file if you want in compact mode or in as a JSON, and finally apply. What happened here now is the connector is creating all rules for this node. Okay, it's validating, will create all rules, and also the connector will create all security groups need for PriCPA. This is done automatically for you. You don't need to be worried about. and the connector will do the job. We'll create the private apps that are applicable to this node. It creates the validate the peers, and also now is creating the security groups. Then everything is automated, very, very highly automated. And that's it. This is all you need. But now I need to tell all other nodes in the cloud that this node exists. Then I need to refresh the same. This refresh needs to be done in all nodes. Okay, I did this manually here to show you the process. But what you're going to do as soon you update via Terraform the bucket, you come here to this AWS System Manager, and each connector has the AWS client, System Manager client on it, and you need to register the connector on the System Manager. This is on the manual, it's very easy to do, but you can see that my connectors are registered. And now I need to tell to my nodes in the Fleet Manager, all my nodes are here. Here are the connectors on Azure that we created. What I will do now is to run a command from AWS, and on the command, run command owner by me. That's a refresh private access peer URL. Run. Let me. I will do via tags. On PriCPA tags, on rate control, I will put do 10 at the same time, and 5, whatever. Now I'm running the command in all nodes in my environment. It's about 23, and we need to wait up to this command ends, because it's updating the nodes in Japan, in Australia, all nodes. And after this process ends, PriCPA will be ready. The information about buckets or terraforms, these type of things, if you go to our medicalbridge.com documentation and support, cloud security connector for Zscaler, Microsoft Azure, and here you have all Terraform templates that we are using, and we are using this connector in AWS, but you can create a bucket in Azure, and here is the example as well. Then everything we are using here are available for you. You can use it as well. Let's see how it goes. It takes some time to complete, because it's validating the nodes, it's checking the rules. It's more checking than the applying the rules. Probably and after it check, the connector does all checks, they'll start completing the values. Also, this has a scheduler. For example, it's updating, pending update, and some in progress. Okay, now all of them are in progress. It's very, very, very fast. It's not the end of the world. In a video, sometimes to wait, but looks long time. But the truth is very, very fast in general. more, more, most nodes should be up now. Taking longer than expected, this node. This is offline. Okay, probably that's the reason. It's not. Okay, let's take a look at the connector now because the most important node are already available. If I do show configuration status and show all peer status, we should start seeing some ones that are active on this. Yeah, it is alive. It is alive with my node already. Some of them are offline, but most of them are all alive now. They are integrated with PriCPA. Then let's try to reach these machines now from using PriCPA. I didn't create a rule for the Bastion host, but okay. First thing first, let's see if I can SSH the internal server. Yes, I created also a rule to to access via web. Then if I check the website, internal web server, I guess this one. Then from my browser, I should be able to. Excellent. Welcome to internal web server. That works. And also I need to check now if I can RDP the other two. If I didn't make any mistake, I should be able to RDP this one. Yes, it works. Straight away. Faster than the Bastion. Oh, that surprised me. That's a good surprise. It's better than the Bastion. Okay, and a Win server should be, yeah, faster than the Bastion, much faster than the Bastion. Okay, that's a good surprise. When I was using the Bastion, that was not so fast, but PriCPA faster. Okay, well, as you can see now, we integrate this machine. I'm using this machine in this site. I'm getting access to the internal machines. That all machines are in my PriCPA environment. That is good. Everything works very easy. Just create the local configuration, put on the bucket via system manager, update all your connectors, and that's it. That's it. Full mesh encrypted configuration with zero trust. Magic. Now let's configure the high availability to complete the setup. And let me show my steps here. Not to make for deploying the peers file. Management networks. I need to configure management networks. If I want to get access to the connector and take a look at the root testing, we did a test. Okay, management networks. This is a particular setup because the connector via zero trust will, if I want to SSH the connector, now I will not be allowed. I need to put my SSH, my management networks, because of course it's zero trust, everything is quite blocked here. Okay, then come in here, connector number one, then put your management network 172.19. This is my first 192.168. That's it. That's default. And the last one is 10.63.1.24. No. Do you want to apply? Yes. Okay. Good. Good. Now we are going to configure high availability, and when this is done, I will configure high availability and PriCPA in the other node. Okay. My current high availability configuration is this. Um, we have only one route, default to the internet, and the control on this route table. Now it's all. Now we need to pay attention to route tables. This route table internal, I'm controlling this route inside the route table. Now I will add these three. I will add this four because I need for next video, but I will add this four to the high availability configuration. Then, um, do you want to change this value? I will say one yes. I will do it manually to show how it is. Route name, the first route name I need to add is this one. The good to do manual is because manual is checking everything. A route table, CS internal, and you can see the errors. A resource group, this one. Okay. Do you want another route? Yes. And my route name is. I will add all of this. Copy. Paste. Route table. Paste. Resource group, same resource group that I have. Okay. Do you want another? Yes. Route name. Oops. See. Route table. Yes, resource group. That's, yeah. I'm creating this route for all private, but you don't need to do that in so detail. For all private IPs, route table, isolated, and resource group. Last one, yes. Route name. Route table. And resource group. Do you want? No. Computer name of the other in the pair is this one. Same than before. And resource group, same resource group. Okay. It's validating all the inputs. Do you want to apply changes? Yes. Okay. I need to create this JSON file. The JSON file, if you are familiar with the connector load, our customers are putting the JSON file directly. But we are going to use the JSON file to configure the second CSE. Okay. We have all routes here, all the stuff, and I will go to the second CSE and configure high availability. Do you want to change these values? One yes, using JSON file, and paste the JSON file. And now on the second one, let's configure PriCPA here. And I will go to PriCPA on the second one. This is all about high availability. I will change local configuration. In this case, I will use token and JSON. And I save the token and JSON here. Token. This is from the first CSC. One token and JSON. You should not put the token on the video because this is critical information, but this is about showing you the options. Now I'm going to apply here. Private access is enabled. And my next step, two steps, local configuration, and the second configuration is load private access peers file. And the peers file is on my bucket here. This is the URL of my peer file. Copy. Paste. And JSON and apply. And now what is doing now is, well, the same that before, checking the apps, creating the private apps, creating the rules, and adding the nodes, and also the security groups for this node. Okay, hold on. My last task is to configure the management networks. 172.19.0.4. The other one is 192.168.4 and 10.63.1.0.24. Okay. If I check now, high availability, well, it's telling me the other connector has the rules, and this is all the routes on this one. And from the PriCPA point of view, the second connector on high availability is passive. Okay, on high availability, this is active, this is passive. Then now we have access to the internal web server. I can get access to this internal web server via PriCPA, and all looks good. Let's do a test. It takes some time. Take some time. Let's do a test with PriCPA now. When we turn off, for example, for a test of high availability, when I turn off the machine that is active, that is this one, the connector B will detect this machine is stop, and will recreate all route tables. Then the change expected is that all these route tables will use the next hop, the other connector. As you can see, there is a lot of work to do here. First, detect the downtime. That takes plenty of time to detect the downtime. Let's wait. Let's wait to see this first. Well, now it is stop. Okay. That is stopping. Oh, what I did. Oh, I stopped the bastion. Yeah, that's fine. That was the machine I tried to stop. Okay. Good to stop the bastion because I have all bastion is gone, but I still via PriCPA. It's good. And now, well, this is something you can do when you have PriCPA. You can stop the bastion. But now let's wait to stop the active CSC. It takes some time to stop. Also, I need to create the access to the connectors via PriCPA. Let's do a copy here. Yeah, PriCPA, and I need to disable the SSH tool. Let's save, and let's do the same copy. Yeah, CPA, and let's say do not use save. Okay. Then now, okay, now the machine is stopped. The active one, the connector number 2, now need to detect the downtime of this, and will change the route tables to put the gateway for exit to the internet and exit to PriCPA via its own gateway. Then we expect here the change via the other one. Okay, that is good. It's okay. Sometimes it's not so fast because it involves the API, and we need to change the route table. And also here on the internal, it's using now the other connector. Then if I come here, um, if I do first thing first, if I try to refresh this, let's open a new tab. Here's the cache. It's static. Okay, it works. And what else? What else? If I, well, I have the RDP sessions here. Let me do the Linux. What is the Linux SSH? I go in win web server via Bastion, web server via PriCPA. Well, it works. This is a problem. My client, SSH client, is not it's not a problem of PriCPA, but my SSH client has some issues. Sometime when I mess with SSH a lot. And what else? We have RDP via PriCPA. We have internal web server. The website works. Everything is up and running. Now we have offline the A, and the B is taking the control of all routes, all traffic, and PriCPA. Then if I go to the B now, unless I did wrong the management networks, let me check this. Edit tunnel is not basics. Well, probably I did some mess with the management network here. Okay, let me take a look from the fleet manager. This is the beauty of the fleet manager, because when you, I know why I can't access, because this is zero trust. And if I, for this node, I didn't create a rule saying you can get access to the connector. That's the issue. I'm blocking the rule. If I want get access to the connector, I need to create a role and add it. Okay, and let's do it. Copy. This is the zero trust is nice, but allow SSH to CSS. CSS, and I will add only my management networks. That's I have my management network somewhere. Come on, come on. This is my management networks. Okay, then I will source IP my management networks. I don't need this one. Can delete this one. And destination the CSC's IPs, and the CAC's IPs are these destinations 5 and 8. Let me edit. Okay, destination. Copy. And port 23, 22 only. Save. Okay. Now repeat the process. Let's go to the bucket. Apply the bucket. Yes. Oh Lord. Yes. Okay, and now go to AWS System Manager here, and here you can go to Run Commands, and Command History. This is the previous one, and rerun. And rerun. We need to wait now for this to get the update. And after this update, I will be able to get access to the number 2. In general, it is if the rule is not related to the node, it goes faster, but it takes about 3 minutes to complete on all of them. What else? The connectors. Just to do something meanwhile we are waiting, the connector will send to you all the information about all changes. There is logs and then you have full visibility of logs and also traffic. Then if you want to see per packet, source IP, destination IP, port and protocol, you have full visibility as well of traffic in the connector. Then even it's a very complete box. And also you can manage via any NMS, network management system, using SNMP, and you can get traffic information or whatever information you want from the device. You can get the information and status, uploads, interfaces, and results graph if you want to know the information. There's interfaces. You can have bytes and data inputs in, out, bandwidth, also in real time. Okay, let's see if run command is executing. We have 16 now. This is this is in progress, but it's offline. That's the problem. And the other one is almost complete. Okay, I want to see if CSC moves to what it is. Is here. Okay, it's complete. Then let's try now, I guess. Cancel this. This is the one that I need to connect now. And success. It works. Okay. Remember, zero trust is zero trust. Don't block yourself. Important. The good is it's just a quick update on the bucket, and you can enable enable the communications again. Well, this is now the connector. This is the high availability. This is the PriCPA configuration, and I'm getting all the information from here. From now, the only task is update the bucket and refresh. Then it's extremely simple to manage. Any rule or anything you want to add, update the bucket and refresh, and that's extremely simple. And it's also sending logs to the my syslog. Well, with this we ended this presentation, and we going back to our steps. We did the create local configuration, the peers file, we create the private apps, we deploy to all CSCs, we configure management networks, we did the routes on Azure, and we saw how the connector control the route and is doing high availability. And so this important point, what happened was this connector was down, and this connector took the role of active and controlled all routes automatically for you. Also, the connector is doing all security groups automatically for you. Then everything is very automatic. We did the test accessing the remote sites and also on reverse. And finally, we did the configuration of high availability. Well, thank you very much for your time. If you have any questions, please contact me directly at alarsen@madehabridge.com, or our sales team, or via our support portal, website or support portal. Thank you very much for your time, and have a good day.